Hello, we are starting a new chapter today. Since you've taken your test on electricity and magnetism, we're going to look at waves, and this is mechanical waves and electromagnetic waves. So let's start with mechanical waves first. And we are going to skip the Bill Nye movie. We'll might show it later, but I doubt it with the restricted time frame we have. You will be working on vocab when I get done talking. That's going to be your assignment today. It's going to be a Quizlet learn and Quizlet test. And you can see that I have the standards that you will be working on. And so again, we're here. It mentions mechanical waves is what we're looking at here. And so we have mechanical waves. And then we're going to look at the mathematics behind wavelength, frequency, and speed, and what the different mediums bring. Medium means, is it going through air? Is it going through water? Is it going through rock? What is it going through? And then we're also going to look at the mechanical waves and how they behave and some of the different things that they see. And then we'll even get into a smidgen of electromagnetic waves. Probably going to have you do that content on your own because it's just basically a lot of reading. And so let's go ahead and get started with, yes, waves. I wish I was at the beach. That's where I was supposed to be this week. But oh well. So what is a wave? A wave is a repeating disturbance. Please write this down. A wave is a repeating disturbance. Hit pause if you have to. I go too fast. Or movement that transfers energy through space. For example, during earthquakes, energy is transferred through the earth. So I do want you to include in your write down that it transfers energy. When a pebble falls into a pool of water, ripples form. And so because it's moving, the falling pebble has energy and it splashes into the pool. The pebble transfers some of that energy into nearby water molecules, causing them to move. And that's what you see. If you are on the surface of the water, either swimming or in a boat, the boat or you doesn't move. You go up and down with the wave, but you don't go a distance with the wave. All waves have this property. They transfer energy without transferring matter. So waves transfer energy without transferring matter. Be sure you're writing that down in your notes. You get to use your notes when it comes test time, so you're definitely going to want to have these written down. Simple harmonic motion, it's motion that is repeated repeatedly, exactly or identically. And a lot of times you'll see this harmonic motion symbolized like this when we talk about waves. And so that would be an example of a simple harmonic motion. Movement of energy, waves are a movement of energy, not medium. The medium only moves as the energy passes. And the medium sometimes hinders the energy, depending upon the speed of the wave in that medium. So if you're making waves, there's a diagram off to the side of this where if you take a rope and you give it a shake, you actually see this hump travel through the wave until it reaches the end of the rope. And it's kind of fun to play with. We would have done that with some springs and had some fun with it, but unfortunately we're not doing that. Again, mechanical waves include water waves, sound waves, earthquake waves, and they have a medium. So this is the major difference. Mechanical waves go through a medium. Electromagnetic waves, there's no medium. They're going through empty space. Light, like sunlight, is an electromagnetic wave. Radiation, the UV rays that we get, are examples of electromagnetic radiation. So mechanical waves, again, they travel through a medium. And some waves, such as light and radio, travel through space. So space is no medium, almost a vacuum. Those are the electromagnetic waves. Mechanical waves are the only waves that travel through matter. So these the two types of mechanical waves, transverse and longitudinal. So we're going to look at transverse and longitudinal next. Wave properties. Wave properties include period and frequency, phase, wavelength, speed, amplitude, crest, and trough. I'm going to kind of narrow this down more to just stick to the standards, and I'm not going to get into the period and all of that. But let's start to name parts of the wave. Again, here's a wave. You see the wave undulating here, and the tops are called crests, the bottoms are called troughs. Any two like positions on a wave, you measure that, and that gives you the wave length. How frequent the wave occurs, like this one, if this was representing 1 second, the frequency of this would be one wave, 2 waves, almost 3 waves per second. If I drew another wave at the top of this that looked like this, and this is representing 1 second, then it's 1, 2, 3, 4, 5, 6, 7, 8, 9 waves per second. So you can see it's 3 times more frequent there. And the wavelength gets shorter as the frequency increases. So transverse waves. In a transverse wave, matter in the medium moves back and forth at right angles to the direction of the wave. So you definitely want to copy that information down. That right angles is key for transverse waves. And then an example of a transverse wave is that picking up a rope or a spring and giving it a jerk up and down, and you've got it. Now, a longitudinal wave, you'll want to copy down this. It moves in the same direction. That's the key part of this. So think of a spring or a slinky, and here you have a tight compressed area, and here you have an open area. You're going to find that the tight compressed areas are called compressions, and these more open areas are called rarefactions. And so that is a compressional, and they're also called compressional waves because of that. That's a longitudinal wave. So there you see transverse, medium moves perpendicular, longitudinal, medium moves parallel. So here's 2 ways to show a transverse waves, and then here's 2 ways to represent longitudinal. This is the way air molecules look in sound when you're doing sound waves. Sound waves, like we just got done saying, are longitudinal waves. When a noise is made, such as when a locker door slams shut and vibrates nearby air particles, they're pushed together by the vibrations. The particles are squeezed together like the coils in a coiled spring toy, and when you make the longitudinal wave, it will travel with it. The compressions travel through air to make a wave. So again, air is the medium with sound waves. And here you can see, here it is represented longitudinally, and here it's represented transversely. So the bottom represents the transverse wave. And so a mechanical wave sound moves about 345 meters per second in air, but it does not move in space. And of course, our eardrums are our whole ear component. The anatomy of our ear is very specialized to be able to amplify the sound, and so it helps us hearing. We'll skip this slide. Sound in other materials. So now think about if you tried to talk to somebody underwater, you're in a pool and you holler at somebody, how different that sounds. So sound waves also can travel through other mediums such as water and wood. And when a sound wave reaches your ear, it causes the eardrum to vibrate. Your inner ear then sends a signal to your brain, and your brain interprets the signals as sound. And here you got water waves. Water waves are not purely transverse waves, so it's a little bit of a mixture. But the water wave causes water to move back and forth as well as up and down. So see, that's why you can say that it's really both. Water is being pushed back and forth to form the crests and the troughs, which is what we essentially call a wave. The low point of the water wave is formed when water is pushed aside and up to the high point of the wave. Ocean waves. Ocean waves are formed most often by wind blowing across the ocean surface. The size of the waves that are formed depend on the wind's speed and distance over which the wind blows and how long it blows. Seismic waves. There was just an earthquake in near Las Vegas this week. I'm videotaping this a week earlier than what you will hear it. And so earthquakes happen all the time on this planet. And what basically is happening is the Earth crust can cause tectonic plates to suddenly slide past one another. So here you see two plates, and there's your fault. And if they do slide or move or shift, then boom, we have an earthquake. And seismic waves are a combination of longitudinal and transverse waves. So you might want to write that down about seismic waves. The more the crust moves during an earthquake, the more energy has been released. And then, of course, sometimes a direct result of an earthquake is a tsunami. It's a sea wave of local or distant origin that is an outcome from a large-scale seafloor displacement, again, usually related with large earthquakes or major submarine, meaning below the ocean, slides, or even exploding volcanic islands can result in this. So here gets into why tsunami occur. When an earthquake occurs, the energy travels outward in all direction. For the epicenter, the energy causes a sea wave to move away at great speed, and it's usually generated from an earthquake. So you should be able to answer these questions. What is a wave? What is carried by a water wave? Remember, it's energy only. That's the one we want to pick. I guess I got off my drawing. Energy only. And then which type of wave does not need a medium? That would be electromagnetic. And what is a tsunami? That is a large wave. And it's a water wave. Okay, parts of a wave is what I want to get to. I started to already kind of go over this, that you've got crests and troughs. This midline is called your rest position. And then from these two segments here to here, that's called the amplitude. You might want to draw one of these and label the parts on your notes so you have that for you. A longitudinal wave has compressions and rarefactions. So compression is where it's tight, and rarefaction is where it's loose. Okay, so you might want to make a copy of that wave too. And so we get into a little bit more of the parts here. I think we've covered it pretty good. And I think I'm going to go ahead and end it there because we're going to start getting into the mathematics, and I want to save that for our next lesson. So I hope you enjoyed this video. I know I talked very fast, but you can always hit pause and replay at any time.